Hi everyone and welcome to this video lecture on evaporation. I am Sumit Kumar and in this lecture we are going to explore what evaporation really is and what are the factors which affects the evaporation. Evaporation is the process where liquid waters turns into water vapor. It happens at temperature well below the boiling point. You do not need to heat water to 100 degrees Celsius for it to disappear or for evaporation. It happens slowly even at room temperature. Water molecules are constantly moving random zigzag movement due to collisions because of their thermal energy. That's what we call Brownian motion. When high energy molecules escape into the air, it becomes water vapor and evaporation starts. As in this figure, it can be seen that the water molecules from the free surface escapes into the air and that is called evaporation. Several factors which affects the rate of evaporation are vapor pressure at the water surface, heat energy, wind velocity, atmospheric pressure and altitude, quality of water, weather condition and size of the water body. We will discuss all these factors in detail in the subsequent slides. One of the most important factors controlling evaporation is vapor pressure at the water surface. The rate of evaporation depends directly on the difference between the saturation vapor pressure of the water, that is EW, which depends on the water temperature, and the actual vapor pressure in the surrounding air, that is EA. This relationship is expressed by Dalton's law of evaporation, which states that EL is directly proportional to EW minus EA. So it can be also written as EL is equal to C into EW minus EA, where C is a constant. Evaporation continues as long as EW is greater than EA. That is, molecules escape from the liquid to the gas phase. When EA becomes equal to or greater than EW, net evaporation stops. And if EA is greater than EW, then we can say condensation occurs uh, instead of evaporation. The next key factor is the heat energy. Solar radiation from the sun is the primary source of heat energy driving evaporation. As heat energy increases, the rate of evaporation rises significantly. Warmer water molecules gain more kinetic energy, escape the surface faster, and turns into vapor more quickly. Wind plays a big role by carrying away the layer of moist air right above the water surface. This removes the saturated air, allowing drier air to come in contact with the liquid. So, more evaporation can occur. The higher the wind speed, up to a certain critical velocity, the faster this evaporation occurs. And the quicker evaporation rate increases. That critical wind speed depends on the size of the water body. Larger surface may need stronger winds for the same effect or same evaporation. The rate of evaporation is inversely proportional to atmospheric pressure. Lower pressure means molecules can escape the liquid surface more easily. At higher altitudes, atmospheric pressure drops significantly. That's why evaporation happens faster up in the mountain than at a sea level, or we can say higher altitude leads to higher evaporation. Another factor, the quality of water, or in other words, we can say how pure or impure it is, or the water is. When mineral, salts, or any other impurities are dissolved in water, they lower the vapor pressure of the solution compared to the pure fresh water. Lower vapor pressure means fewer water molecules can escape into the air, so the rate of evaporation decreases. For example, under the same condition, evaporation from seawater is typically about 2 to 3% slower than from fresh water. Evaporation reaches its maximum in the afternoon when solar heating is strongest and the temperature is peak. It is significantly higher in summer and much lower in winter due to difference in heat energy and air temperature. Cloud cover plays a big role too. Thick cloud blocks solar radiation, reduces surface heating, and often increases humidity, all of which slow down evaporation. Now, let's look at one of the important factors affecting evaporation, which is the size of the water body. Evaporation mainly happens at the surface of water, where water changes from a liquid into vapor due to heat from the sun. Larger surface area lead to higher evaporation. For example, a large lake or ocean has more water exposed to air and sunlight. So more water molecules can escape into the atmosphere. Shallow water body experiences more evaporation. This is because slow water heats up faster than deep water, which increases the rate at which water evaporates. Thank you everyone for your attention. In this lecture, we discussed evaporation and the factors that affect it. Understanding these factors is important because evaporation plays a key role in the water cycle and in managing water resources. Thank you for watching. Jai Hind.